Welcome to the show, where tech begins to flow. AI with Kubernetes, Edera's here, you know. Spotlights on the scene.
Can you hear me?
I can hear you.
Okay,
Can you hear me?
I think we're good then.
Welcome to the show, where tech begins to flow. AI with Kubernetes, Edera's here, you know. Spotlights on the scene, secure and so pristine. No matter where you run, we keep your infra clean. Edera Project Spotlight, we're taking you so high. Secure by design, join and see why. Innovation at its core, pushing limits, wanting more. Your data safe and sound, always helping you soar. Innovation at its core, pushing limits, wanting more. Your data safe and sound, always helping you soar. Edera Project Spotlight, we're taking you so high. Secure by design, join and see why. Innovation at its core, pushing limits, wanting more. Your data safe and sound, always helping you soar. From cloud to on-premises, we achieve the best. Tech that fuels your dreams, welcome to success. Welcome to the show, where tech begins to flow. AI with Kubernetes, Edera's here, you know. Spotlights on the scene, secure and so pristine. No matter where you run, we keep your infra clean. Edera Project Spotlight, we're taking you so high. Secure by design, join and see why. Innovation at its core, pushing limits, wanting more. Your data safe and sound, always helping you soar. Innovation at its core, pushing limits, wanting more. Your data safe and sound.
Welcome back, everyone. Welcome back to another Cloud Native Club Project Spotlight episode. Today I'm excited to have with me Lewis. He's going to explore Edera. Not just the name, much more. Lewis, thanks for joining us. Do you want to give a brief intro to yourself?
Yeah, and cheers for having me, Steve. So, hey everyone, my name's Lewis Parry. I'm a staff solutions engineer here at Edera. I'm based in the UK, so I'm in a city called Cardiff in Wales. And yeah, so in regards to cloud native, I've been around for a while now. I've been around a while. I started working providing training with a company called Learn Kubernetes. And that was great because I got to work with so many people, helping them see Kubernetes. It was this new thing back then. And it was a case of, this is a pod, this is a deployment, here's a service, config maps. But that led me to other gigs. So I worked at Jetstack for a while, then Control Plane. Then I moved towards a product. So I worked with a company called ChainGuard for a couple of years. But this year I've moved to the most exciting one yet for me, this company called Edera. And yeah, we're newly formed, but we've got some amazing, amazing technology behind us already.
So let's get the big one out the way first. Congratulations on the seed round. I
Oh.
can't wait. I now can't wait to see the photos of your booth at KubeCon. I assume it's going to be massive.
Oh, we've got plans. There's so yes, we will be in Salt Lake City. And so we got some plans out there, but also I feel like London, KubeCon London.
It's coming
Back, yeah, home from hometown, and yeah, that I think that'll be huge for us. So yeah.
So I have to admit I can't believe I actually have a Liverpool fan on here. So you better make up with it with some stellar insights into container security. So I'm kind of curious about Edera's origins. Like, could you share the story of kind of how it came about, kind of what inspired its creation?
Yeah. So Edera, so we have three founding women. And so that's the first thing for me with Edera. It's just a case of we're breaking this bias. We're starting, and but originally it was Alex. Alex came up with this concept, which I'll be demoing in a moment, and then the crew started coming together. So there's Alex, Ariadne, and so our three founding females. They got this company together with this product, and it's this for me. It's this beautiful thing about timing. It's a case of having the right people with the experience, but also as an industry as well, where we're seeing ourselves go to now, and especially with AI. It's the timing has been so precise, but it gives us such good momentum to be able to do things right the first time around this time.
Cool. So yeah, one of the questions that I like to ask is: assume that I'm an Uber driver. Kind of explain Edera to me as an Uber driver.
Oh, cool. I do enjoy these, and yes, this is what I usually do with Uber drivers as well. So Edera, it's with our workloads, and it's a case that whenever you use your phone, whatever compute you're using, it's running somewhere, and what we'd often call the cloud. And I think that's synonymous now that people think of the cloud. Now, we trust in security. We trust that best practices have been put in place. We trust that when we provide our information, we trust when we require something to be done, that security is being taken into place, and then that that bad actors or it's not going to get distributed. And we get those emails when we find out that someone's been hacked in this database, all those things. What Edera, we're here to make it simple again. We're here to make sure that when you run your workloads, they are absolutely isolated. I'll give a demo as to what isolation means, but this is more of a case of take an example of school. If you've done all your homework and you're in an exam, you don't want someone looking over your shoulder taking the answers that you've worked hard for. And it's the same with our workloads. When we've got workloads, when we've got critical information in there, we don't want people looking into it. But also when we do run things, and again, with like hardware, it's like we want to control what workloads can connect onto what hardware as well, because that's the other problem as well. We can't give everything away. But I hope that it makes a bit more sense in demo, and I probably need to work on my Uber pitch a little bit more.
Just yeah, I'm not an Uber driver, so you got past it with me. So I was reading through the the Edera website, and it mentions things like Type 1 hypervisors and a Rust based control plane, and I kind of understand that myself a little bit, but that's kind of a lot of words.
Yeah.
So could you kind of break down what we mean by a Type 1 hypervisor kind of before we get started?
Yeah, absolutely. And again, if you're working with Kubernetes, if you're a developer, you're probably used to the concept of a virtual machine, a VM. Now with virtual instances, we got type 1 and a type 2. Type 1 is where we're at that base level. So it's a case of you've got your hardware, hypervisor, then you have your operating system on top of it. Now, a type 2 is where you have your hardware and operating system and your hypervisor on top of that. Now, if I'm saying words like hypervisor, if you don't know what a hypervisor is, then please reach out to me. I'm more than happy to have a bit of a discussion with us. But the point here is that there are levels in between. And when we're talking about complexity and attacks, it's a case of if you're running on top of something else, and as I'll show with a breakout, it means that you can gain access to lots and lots of things. Whereas if we have isolation at a lot lower down, then that isolation gives us more security and equally now performance as well. So those performance enhancements are huge.
Cool. So let's get switch into the demo and see what you guys have been cooking.
Cool. So I guess going into this demo, I was going to use one of my analogies, and anyone who's worked with me or seen me for even a brief moment in time knows I love my analogies. I was watching, and I will share, I was doing the ironing and I was watching Netflix, and there's an interview with James Cameron from Bill Gates regarding AI, incidentally. And James Cameron was comparing it to the Titanic and saying, the Titanic wouldn't have hit the iceberg if they didn't sail in a night. And the purpose there was they were pushed into an environment where they had to get to the harbor on a time frame. So they made a decision to go through the night. And eventually it hit the iceberg. And again, like spoiler warning, if you haven't seen the movie Titanic, the Titanic sank. But with that, whilst we were seeing everything was put into place. So there's people trying to get into lifeboats and so forth. But in doing so, when it sank, then there's a financial cost. There's the boat is no longer on the ocean, it's under the ocean. You've then got the brand reputation. So then all of a sudden, the Titanic, which was going to be the most sturdy vessel, is now at the bottom of the ocean. Finally, like payouts, because with this being all a bit like lighthearted, like there was a loss of life from the Titanic. And so from a decision that was made, there was a significant loss of life. And even this year, there's been a loss of life because of Titanic. So when we make decisions, they can be critical. And that's, for me, why security is so important. Now, comparing the Titanic to Kubernetes today, and there is that nautical theme within Kubernetes. I do get that. But for me, and I totally ripped this off James Cameron, but AI is that iceberg ahead of us. And for me, part of what we're doing with Kubernetes, and Kubernetes is now 10 years old. And 10 years ago, AI was completely different as to what AI is today. And over the last couple of years, we can see it with the growth of that market. It's here to stay, but we're also adding in GPUs into our Kubernetes environments. And to an extent, today is adding this hardware. So I'm going to give a demo just to show you what can happen when we don't isolate our workloads. So on my screen here, so I've got this concept of a leaky vessel.
Of course.
So let's just start there. So if we have a look at the leaky vessel YAML, this is just a simple bit of YAML, a Den & Parry leaky vessel container. That's publicly available. You can pull it. You can have a look into inspect it if you so wish. In there, I've baked a secret. It's just on a sleep loop, so it's not going to do too much, but I've baked a secret into the container. Also in this YAML, I'm baking another secret into the environment, the super orchestrator secret of this is fine leaky. So we're going to do our Kubernetes. It's kubectl apply -file leaky vessel YAML. And we've created, hold on there. Yeah, no, we're still on. Yeah, I can check on my phone. People are still seeing us. I think they can hear us. So let's crack on. Let's do it on the night. So we got to a stage, I was talking about multi-tenancy, and I was saying the problem that we have with this is that if you're running workloads across a cluster where you can't have them talk to each other, well, we've just seen that this can happen with a setup. Now, there are security tools in place to then stop you from being able to run a Kubernetes workload with privilege, with the host PID. But that has to be set up with configuration. And to me, that's happening, maybe it's happening at the top layer. And then if you can bypass that, then you could still potentially run these. You're trusting that configuration. Now with Edera Protect, we're starting right at the bottom. And as Steve mentioned about our type 1 hypervisor, it's a case of we're before the OS. So let's do a quick little introduction to zones. So within Edera Protect, we have a concept of a zone. So the zone is in that hypervisor layer. So let's talk about bare metal hypervisor operating system. So your operating system, when you run Edera, is in its own zone. That zone has its own kernel, and you can specify which kernel that it has. So when you go to run processes, containers, or pods, you can specify that they have their own zone, and that zone will have its own kernel. And that's what allows us to have this isolation between the two. So we can still see here that underneath, we've still got our leaky vessel running and it's still sleeping. But what we're going to do is that we're going to have a look at our Radar Edera. So if I do diff, Radar, and Radar Edera, so I got Radar Edera YAML there, and we can see the difference here is that we've changed the name to Radar Edera. We've added an annotation here. So with Edera, you can annotate which kernel you want to use. So in this instance, we're using kernel 6.9. We could also specify the amount of memory, but we'll have a look into that in a moment. And finally, we're specifying our runtime class as Edera. So instead of using containerd in this instance, we're going to be using Edera to run this workload. So without further ado, let me do a kubectl apply -f radar Edera. And it's really helpful when you spell kubectl if you use that silent E. It's otherwise it doesn't recognize it. Binary, there we go. So we've created that part. Now let's just make sure. So we'll just get rid of our old, we'll just get rid of the old radar. Delete pod radar. Cool. And we're going to exec now into our radar Edera -bash. So straight away, we have not changed this container. You saw within a diff, that container didn't change. So this is still the same container that I ran a moment ago. The one subtle difference here is that you can see that this one is root at Kubernetes Titanic Radar Edera Radar. So it's running in Kubernetes, it's within a Titanic namespace. We've named the pod Radar Edera, and we're within the Radar container. Now, just when we mention that kernel, if I just do, I'm this lower pane, I'm SSH'd onto the cluster. So if I do uname -a, we can see that the kernel that's run within this machine is 6.1.0. Whereas when I run uname -a within the Edera container, we can see that we are on 6.9.8. So, all right, we have a different kernel available to us within this container. Now, if I run that command of psfo, I can't see all those processes that we previously saw. I've still requested privilege access. I've still requested host PID access, which I incidentally have, but within that zone, this is what's available. So again, within a zone, and just with these concepts, if you're thinking, a zone isn't specific just to a container. If you wanted a container per zone, you can do that. If you wanted to run multiple containers within a zone, you can do that. If you're running an operating system and you want to put that into a zone, you can do that. And that's what we're doing here with Edera. But in us doing this...
Can I run a pod per zone, Lewis?
Yeah, definitely. You can definitely do that. And again, you can specify which kernel you want to go in there. So yeah, the consideration that you'd want to take within zones is something about your threat boundary, the security boundary. So it's a case of what do I want to be able to, in the event of accessing that host machine like I did previously, do I want this to be interacting? So you could say that I have a pod for customer A and a pod for customer B. Those pods have their own separate zones. That prevents that attack that I just showed you a moment ago.
Yeah,
now,
that makes sense.
So with me saying that as well, I just said that a zone can have a host operating system. So we didn't do this earlier on, but we still have our leaky vessel running here. So kubectl get pod. We still got leaky vessel running and it's still asleep, I think. It's just filled with Z's. But because I'm SSH'd onto the machine, if I do a PSFO here, now this looks similar to what we had initially. And that's because this is the host process ID. This is the machine that had all those host processes. So here, I can grep sleep.sh and I can see that process. So the problem I've got at this moment is that I can still access it from, because the leaky vessel isn't using Edera, I can still see this process from the VM that I'm SSH'd onto. So what we're going to do is this. I'm going to clean up my pods. So I'm just going to, let's clear the screen. We'll go down, kubectl get pods. So we're just going to get rid of leaky vessel for a moment. Kubectl delete pod, leaky vessel. Actually, I'm going to do a -- force, if I can spell force. There we go. So that's going to clear itself out. So whilst that's clearing out, we'll do diff color, and we're going to spell it the American way. And we're going to look at the difference between a leaky vessel and a hardened vessel. So we've renamed it from leaky to hardened vessel. We've given the annotations again. So we're specifying this kernel as 6.9 again, and we're specifying that this is going to have 600 meg of memory. Finally, we've got the runtime class of Edera. And also, just to prove this, we're changing the environment variable from this is fine leaky to this is fine hardened. So if we do kubectl get pods, oh, I didn't apply it. I applied the wrong thing. Let's just do that again.
It's the joy of unscripted demos, right?
Yeah, no. Hey,
dangerously.
my life is an unscripted demo.
Both.
So well, I'm just going to delete the radar pod as well, just to keep this a little bit cleaner for us. So that hardened vessel, that's the same leaky vessel container that we had previously. So that still has that leaky environment variable baked into that container. We've also got the environment variable within the YAML that we've used within Kubernetes, but we changed it to hardened to help identify it. So kubectl get pods, and we should see that it's running there. So let's check. So keep me honest pod, are you sleeping, vessel? So we can see that it's sleeping there. So again, the container has not changed. What's changed is now that we're running this with Edera Protect. What that means is that it's running in its own zone. It's not in the same zone as a host. Can we prove that? Well, yeah, let's come back to this bottom screen here, and we'll do a PSFO. And again, we've got lots of processes here. So now let's just grep out. We'll do the grep sleep.sh. And I've got one returning, but the only return I'm getting is the grep itself.
Can you come up a bit, Lewis?
Yeah. Cool. So PSFO, grep sleep, and the only process that's returned is the process that I just ran here, grep.sleep.
So when you specify the memory, that's the memory for that specific container with that specific kernel, correct?
Oh, great question. That memory in this instance is for the zone. So because with that annotation in this context of this pod with that zone, we're specifying that that zone has given it 600 meg of memory. So let's pick that point up. So we've got a tool at the moment. And again, we use this predominantly for demos, but we got protect kutl zone list. So let me just make, there we go. I'm just using Kitty at the moment. So for my terminal. So here we go. We can see that we've got two zones that have been created. One was for another pod that we're running, default Postgres, but here's the one that we've been working on. Kubernetes Titanic hardened vessel. So that's just showing me that that's got its own zone. So now using protect kutl zone top, we can see here that it's currently got 557 meg of memory. Used is 41.6 meg, and for free memory is 520.
Of course, Postgres is taking the most memory.
Of course, but hey, there's no shame There's no shame with our work. I would like us to give our Titanic pod some more memory. So
Let's do it.
yeah, so let's just do. It's probably a little bit tight here. That works. That works. So what was I going to show with this? I need to SSH onto bronze first. That's what I was going to do. I was going to stick a watch in here. So we're going to do kubectl get pods. So there's a binary called watch. So if I do watch bang bang, that's the bang bang will be replaced by kubectl get pods. And every 2 seconds, this is just going to be refreshed. So when I spoke about what Edera Protect is, and again, a type 1 hypervisor, so we've got hardware, we've got our Edera hypervisor, and we've got our zone, sorry, in that hypervisor, we've got our zones, and then we've got our operating system up there. We've also got our leaky vessel container up there as well. Because of the way that this has been architected, and again, this is just from the experience of a team that we have, we can dynamically allocate additional resources to our containers without taking them down. So we can do, let's...
It's like you knew what question I was going to ask.
I didn't, did I even ask you to ask us a question?
No.
So I can't do it on that one because that's from a different zone. So Titanic, hardened vessel, hardened. Like, oh no, I've done, sorry. I'll do this at this moment in time. Again, there is still no shade, but I am dyslexic and doing live demos, and especially when you don't have all your auto completion set up.
You're doing great.
Cheers, mate. See, protect. Oh, because it's a hyphen. It's a hyphen. It's always, it's not just letters I struggle with. Right, let's just get rid of that. Let's do that again. See, this is what I like to do with demos, is it's like I like to use words that I really struggle to spell. And then it's like
it's also a realistic demo, right? Because everyone that works with Kubernetes is doing something similar, right? There's the easy like autocomplete parts that people have, like their alias kubectl to k, but
yeah,
when you've got these long pod names, you know, these are real problems.
yeah, and again, like this is our shared demo machine at this moment in time. Like I love those, and maybe we'll discuss that in a moment, but it's just those are the things that give us quick wins. So as I say quick wins, as I try to spin this up again. So we had the watch here. So watch kubectl get pods. Then here we just want to do protect cattle zone top. So this is cycling. This is just monitoring what we have available. Kubernetes Titanic there, it's got 557 mega moment at this moment in time. If I hit enter, oh, okay. Why am I? It's for hyphens. It's a hyphens. So it's that hyphen there. Gosh. There we go.
There we go.
Like from all my ineptitude, it's everything I can't do. We've built all the hard bit. It's just me spelling things correctly and also using the correct hyphen or underscore. Jeez, this is my demo life. This is what we spoke about earlier on. But after I've taken all that away, we can see the hardened vessel is still there. It's been up for 7 minutes and 6 seconds. It should have probably been up for only 3 minutes if I could spell things right. But still, we've seen that what we've done is that we've allocated additional memory to this zone, which incidentally, I keep saying incidentally now, if I do kubectl exec -it hardened, after this, I'm going to just rename hardened vessel just to something a lot easier.
Just call it Lewis.
Yeah, and just that's what my parents did. So,
name.
Yeah, and free -m. For some reason, that's all gone. But we can see here within the container itself, we've got increased memory of up to 4 gig. So let's just see if we can do a watch on that. No, because it doesn't like that bang bang. So watch, free Ivan MH. Oh, gee whiz. Last one. All right, demo gods. Let's go. Let's go. Watch, free Ivan MH. I'll leave that. Why is that? Why anyway? I'll raise this up
No,
as a
no,
bug.
you'll be
Free.
good now. You put an F at the front. There you go.
There, yes. Oh God.
F for effing watch.
That's as per the hoodie.
Exactly. That's why you typed it,
Yeah.
right?
So right. So look, I've proven that the pod doesn't go down. I'm going to use this one for a moment. We're going to go up and we're just going to change it back down. So protect, cut all. It's not even in the history. I can't believe that. This is taking the mickey. Right. Actually, what we'll do is we'll close that one. We'll close that quick. And then I did that all. Okay. Protect. I'm gonna own this one. Protect hyphen cattle. Update resources.
Could you scroll up a little bit, Lewis?
I will do. Let me just get this last bit done and then I'll scroll up for the screen. But it's mainly just to focus on what's happening in the pod on the top, is that what we're going to do is that as well as like scaling up, we can also scale it down. So we're going to scale this down to a gig of memory. And I typed it correctly, so we can see in the top, and this is within exact native container. Using free MH, we can see the memory that's available, and we can see that that's dynamically gone down.
That's neat. I can see a bunch of use cases for that already.
Yeah, and this is like, this shows the power and the control that we have at this level. And again, this could only really happen because of this moment in time, because we experience that we have with this technology, we've seen where it's shifted to. But also, like, this is written in Rust as well for memory safety. So part of this is as the zone, because the zone is just taking additional memory elsewhere off that hardware. And when that memory is taken, that might have been used by a separate zone earlier on, but that memory is scrubbed. So there isn't a way for this information to leak between zones, which again is just huge. Now, throughout this, like, and again, from my history of cloud native, I've come from the top and I've worked my way down. And at the last place I was at, we were working at securing containers. And now we've gone deeper at securing the actual runtime. Now, it isn't about just top down though. And as we mentioned, and a lot about AI, it's a case of AI is this hardware component, which is just the way that we use it is revolutionized. It's the graphical processing unit is used for math, not, well, anyway. So what am I blabbering on about here? The zone that we can put the driver for a GPU into its own zone. Because today, if you put the driver in place, that's on the operating system level. And with that first initial exploit that I showed you, that gave me access to the whole machine. That gives me access to everything, including the GPU. With Edera Protect, and this is how we harden and protect our AI workloads, is that we put the GPU device driver into its own zone. And we get to select which pods or whichever zones essentially interact with that device driver. And it doesn't just have to specifically be a GPU. This could also be any other hardware aspect, so network device, disk, and so forth. So it allows us, not just from the top down, so not just from the abstractions of Kubernetes, but we saw with YAML, I can put it in the YAML there and I don't have to change the container. But we can also secure it from the ground up. So utilizing this, you don't have to change the containers. We've put a boundary around them and it allows us to run them safely.
That's awesome. Like, I can see so many use cases, right? If we think about, like, eventually, and I'm sure you guys are already thinking about this, like a mutating webhook, right, that will have a look at the structure of your YAML and essentially add these Edera annotations in, so zones are getting created and deleted on the fly, based
Absolutely.
on some kind of labeling taxonomy. And if you haven't done that, I'll take the royalties.
So, well, that's an interesting thing because I see that you've got a guest from Kyverno coming up as well. And so that's what I use in one of my demos is a case of I can just put a mutating webhook in place there. And as you can see, it's with that runtime class of Edera, you just pass that in and the rest is done. And also, there's so many interesting parts coming out here because we are at the root of it. The world is proverbially the oyster here. With those resources, we we want that abstraction. We want this as simple as possible. We don't want to shift left. We don't want to put more onus onto other people. This is just a runtime platform. You can run containerd alongside Edera Protect still. So there's no reason why when you put this onto a node, you have to just trust us, because I feel that trust is earned. And that's what we're doing. That's why we're doing these live demos. We got live things working. Again, I'm probably going to install the autocomplete feature just to prevent that from happening next time. But the point that I'm just trying to make here is that you can start using Edera. And as I showed in that demo, if you've got a workload that is really either really valuable to you that you don't want anyone else looking into, use Edera Protect wrapped around it, and then you can see from host OS you can't look in. Incidentally, if you're running if you've got really old code in one of your containers, end of life, filled with CVEs and a huge threat to your whole organization, like there's a reason why you haven't fixed it yet. And it's like you can either spend more time thinking how you're going to fix it, or you use Edera Protect where you don't have to change the container, put it into Edera Protect, have it in its own zone, and then it gives you time to focus on actually fixing that code or going on to the next thing. Like use a strangler pattern and start building microservices around it so you get new code so that you get rid of that.
Leave it.
Someone else's problem. Like,
Exactly.
but like to be fair, that's what I did for most of my life, especially my 20s. Everything was someone else's problem.
Oh, I thought you were gonna say everything was a strangler pattern. I was getting worried then.
Oh no. And just again, it's the problem of having a double-barreled surname is that my history follows me quite quickly. So please don't search for my name. But I think that's the thing about security, and it's a case of why I have so much pride in the companies that I work with now. It's a base of like, yes, I'm working, yes, I'm doing code and doing these things. Yes, that's great. But I'm also a consumer of so many industries and organizations, by choice occasionally. Having a security model there to make sure these are safe, and it's helping insurmountably the whole industry. And so if in helping get us more secure, and we don't want it to be a difficult thing to become secure. Like the path of least resistance is the easiest one. So we want that. And that's what we're also trying to show here with Edera. Just change in that runtime class. And again, like you said, you could have a mutating webhook. You don't even have to do that. And it gives you that protection.
That's great.
And incidentally, finally on that though, it's just performance though, because we're seeing like for like performance on bare metal. So usually it would be that security is a loss of performance, not with us. And if anything, you can run workloads on the same node finally. So having that means that you don't have to have 8 different clusters for 8 different customers. You can have a single cluster, which saves you on resources of running those nodes, but also managing them. It's like if you don't have to manage 8 clusters, then you've only got to focus on one.
That's a dream, right? So obviously you're aware, or maybe you're not aware, that we have a tradition on this show whereby the previous guest asks a question for the current guest. So Joe from Cloud Curry asked this question, which is, what open source project are you currently working on right now that you're not working on in your full-time job?
Hey Joe, great question. So as you mentioned at the start, Edera is a startup, and as the bags under my eyes can allude, we're doing a lot right now. And so my spare time is at an absolute premium. So I'm not contributing as much as I wish, but the projects that I really enjoy, and so one open source one that I use is Chezmoi, Chezmoi, and so it's a .files manager for my machine. So it's a case of if I lose my machine, I'm quietly confident that I can spin it back up. Incidentally, yes, I am aware of Nix, and I'm migrating towards Nix, but equally Chezmoi for me is just chef's kiss, and yeah, so I really do enjoy that. And well, contributing to open source as well. I think there's an aspect to it where we always think it's about code. It's about contributing to a Git repo. Part of it is, yes, but there are so many other aspects. So like this podcast, for instance, like coming here, that it's building up a community, it's sharing knowledge, it's sharing experiences. I used to run a meetup called Cloud Native Wales, where we wanted to bring talks to where I've grew up, and we created a huge community, and that was amazing. I'm also an organizer for KCD UK, which you'll be speaking at, Steve, next month. Not just to
Yep.
remind you, just
I'm
to
excited.
just we'll be in London.
Just to remind me to finish my talk.
Yeah, I'll be there with a 5-minute sign, 2 minute, and yeah. But the point here is that to contribute to open source, it doesn't. If you're at a point where it's like, well, I don't feel like I know where to contribute with code, then even like turning up to a conference is, in my opinion, contributing to open source, because a conference can only run with attendees there, and we're sharing knowledge, sharing experiences. So yeah, I kind of hope that answers a bit of Joe's question.
Amen to that. I think even just attending conferences and making a statement, whether that statement be something that like, just a question or whether it be from experience, it's all about learning at the end of the day. People just sharing their experiences, and hopefully someone takes something valuable away from it. And I always say the same thing, right? If you give a talk to 100 people and one person takes one thing away from it, then it was a valuable talk, and it was a
Yeah.
useful time. So does anyone in the chat have any questions? If they do, post them in. If they don't, then I'll ask you a couple.
And whilst that's happening, I think to your point as well, because it's a case of, if you are getting started and it's insider secret. When I shared that I started out learning Kubernetes, I was learning Kubernetes at the same time. And so I was contributing back, because everything, the friction points that I was experiencing, I had to learn, but then something that took me 2 hours to figure out, I could share in a minute to someone else. Something that took me 2 weeks to figure out, I could share to someone in 10 minutes, and so forth. And the reward that I had back from there as well was that just being seen to be helpful. So chop wood, carry water is used a lot. And a lot of the people that I looked up to when I got started, thinking, wow, that'd be amazing, I helped where I could, and they noticed that from me. And so whenever I was there to ask for help, or even not when I needed to ask, they reached out to me to say, do you need anything now? That's how we build a community. And it's a case of, and part of it is trust again. Like, please trust me when I say, when you do this, eventually you are seen for it, and it does come back and it does help. But anyway.
What exciting developments and plans can we expect from Edera? Obviously, without giving away the whole entire roadmap.
Oh, the whole roadmap. Honestly, this is, I shared this yesterday with the team, because again, a lot of the team are based on the West Coast of the US, and I'm based on the West Coast of UK. UK, the best West Coast is the UK West Coast. And it's just amazing, because each day I wake up, I look at what's been done the day before, and it's huge. Like, the movement that we're making, the progression is just fantastic every day. Back to that, like when I'm showing you things like, here's how we can manage resource allocation. Well, wouldn't it be better if this was automated? And it's, oh yeah, so it's automated. And these are the features that happen each day. And also, so if I haven't lost you so much about zones, and we were discussing about the new features on Mac OS the other day, and there's a new feature on Mac OS which allows you to connect onto your iPhone via your Mac. And one of the team decided to delete all the Electron apps on their Mac, because it's like, finally, I've got a safe place to be able to run them on my phone. And so then that gets thinking, like, this concept of zones and having that safe space on your compute, then that's the Edera roadmap. It's a case of, we're starting with containers and Kubernetes, because that's a cloud today, and that's where we can help most people where they're at. But then down the line, it's a case of, well, let's go further, and whether that be on desktop machines, whether that be on the edge, and so forth. But right now, I feel like this is fine moment is the cloud, but also the incoming AI as well. And so we need to make sure that what I've shown you is, because personally, that's what I'd expect as a default, is to know that there's isolation in place. So us making it as simple as possible to make sure that that isolation is there, then that allows us to focus on the difficult challenges and allows us to progress to the next thing.
Yeah, just a few annotations away by the looks of it, which is great, right?
Oh, and I think those annotations will go as well. Like, I think that's a nice thing. It's always nice to have that, and equally with demos, it's good to show, because it's like, this is, when you can type vessel and hardened, which is and use a hyphen instead of an underscore. But once you can do those difficult things, then the ability to increase and decrease resources dynamically. And also, maybe that's the other thing, just to say as well, because yes, I'm showing you memory and CPU there, but then also it's the capability of allowing to say you've got access to this now. And we don't have to restart the container for that because the zone has access to it for a moment in time. So these advancements, again, it feels like when I used to give Kubernetes training is what I thought we had, but now this is what I wish we all have. So and that's why we're doing it today.
So I've spent a bunch of time asking you a bunch of questions. Do you have any questions for me, whether that be Cloud Native Club or just broader Cloud Native community stuff?
Yeah. So we spoke about football, and again, sorry for your loss with Man United a couple of weeks ago. To Liverpool,
waiting for that.
incidentally. So, yeah, I just, I'm sorry. I'm petty in that way. Um, well, I guess so. We've connected quite a bit about football. To the people who are still celebrating their morning soccer. Um, what lessons have you seen from that aspect of whether it be team, whether it be individual, and so forth? What have you seen there that has continued to bring you into well, allows you to progress within this community?
So if you're based in the UK, get yourself to KCD London, and I'll go in a lot more depth about this. But I think one of the most important ones is teamwork. Like it's obvious, but nothing will ever replicate a football team and the camaraderie that you have as a bunch of individuals. But as the sum of their parts, they can achieve much more. And I think that's the same in technology in all of the companies that I always work in. Right? It's everybody plays a pivotal role in moving the company forward. It's not just necessarily the engineers on the product team. It's the people that set the roadmap. It's the people that do the marketing. It's it's HR that are helping us hire the right people, and it's really about the team is bigger than just the team that you work in, and actually it's a ripple effect of kind of when you think about the first team, the reserves, and then the academy, the work and kind of culture that you build in the first team actually ripples down to other teams. And if you take those kind of academies and reserve teams as just different product teams, or maybe just kind of different verticals in a larger enterprise, the changes that you're making there can actually have big effects. Some of them are well seen, and some of them are kind of silently seen. But I think that's kind of a big one. I'm not going to give you too many spoilers because otherwise I'm going to give you my talk. But that's kind of a main one.
Well, you know I'm going to be there for your talk, so there's
Five
but
minutes.
and without that resonates as well with me where so within Edera is the concept of a team, because the one thing that I wish, again, I learned a lot quicker in my life than I did, was that it's okay to be me. I always try to be someone who I wasn't, and then in doing that, I always fell. And being part of it, like as you would if you've got a goalkeeper who's trying to play up front, it doesn't always end up to or incidentally the other way around. So but then that's a full function team. And to your point as well about firsts and reserves and so forth, it's that mentorship as well that I'm seeing within our industry. It's a case of
Exactly.
leaving it better than you find it, and
Yep.
just make sure that yeah. So oh no, that's all. Thank you for that answer.
No problem. Yeah. So as you know, we have a tradition. So what's the question that you'd like me to ask the next guest? And it can be anything. It can be technical, non-technical, personal, whatever you want.
Oh, I'm going to set them up. Right. Keep the thing about cloud native, and I absolutely loved it when I joined this community. It's a case of there are so many different silos of the industry. What do I mean by silo? Well, it could be storage, it's got networking, we got running our workload, we've got security. There's so many different things, but I always felt that people were bringing their A game. So it's a case of being back in the teams. It's like, this is the best way to do networking, so let's do it this way and store. We all have our weaknesses. So where did they probably have not as much knowledge to begin with, but are thankful to being able to learn from it? Because for me, I've learned so much about Linux in general just from this, like that I started from the top and then I've got all my way down to the processes and the namespaces and such. So yeah, I guess that'd be my question. What's helped them learn more from focusing on things that we didn't necessarily know coming
Okay.
into it?
Good question. I'll make sure that I ask it. So yeah, I just want to wrap up. Thanks very much Lewis, for joining us today. Thanks for taking the time and showing us some new tech with with the Edera Protect. I'm excited to see what happens in the next couple of months. It'll be great to get you or someone else from the team on next year, and we can see what kind of progress you've been making, and you can show us some new stuff. But yeah, I just want to say thanks again, and don't forget to check out Edera at edera.dev. I won't say the slogan. And yeah, stay connected with the Cloud Native Club on Twitter, LinkedIn, and YouTube. And until next time, stay Cloud Native.
Thank you.